Under 2.4, we are going to understand something to do with inverse functions. And the inverse of a function performs the opposite operation to the original function. Of course, it takes the elements in the range of the original function and maps them back into the original elements. It takes the range and maps it back to the domains. Of course, for this reason, inverse function exists only for one-to-one functions because it maps the range of a function back to its original domain. So if we had many-to-one function, it is not possible to map one range into many domains. It's not possible. There's something that we need to highlight here. Functions of the function of x and the function inverse of x are inverses of each other, such that f followed by the inverse of x is equals to the inverse of x followed by the function of x, and all of them will end up giving you x. It takes you back to where you started. If it is addition of 2, then the inverse subtract 2. The graphs of y is equals to fx and y is equals to f prime x are reflection. This is point number 1. Point number 2 is it's a reflection along the line y is equals to x. The reflection along that line y is equals to x. Because when you reflect anything along the line y is equals to x, whatever was x now becomes y, and whatever was y becomes x. The domain of the function of x is the range of, the domain of fx is, the domain of this is the range of f prime x. In other words, what we are saying that the solution, or rather, the domain of fx is the range of f prime x, meaning that whatever we started from, x for that matter, is what the f prime x will give us. So where we started from, effecting them along the function of x, and again upon the inverse of x, it takes you back to where we started. We are going to see this in a diagram. And finally, the range of fx, the range of fx is the domain of f prime x. After we effect a certain variable x upon the function f, whatever results that we are going to use or to have is what we are using as the domain of the inverse of that x. In other words, if you look at that diagram on page 24, it talks of if we had a function of x, and then we have y is equals to, this is the line y is equals to x. If this was supposed to be a 3, then it's reflected along the line y is equals to x, and this point is reflected here. So you can see that's a point of intersection between the mirror line and the original function. So we are going to have a function that this now we call it f prime x. It's a reflection along the mirror line, y is equals to x. Having said that, I think it is important to talk about example 13 with this knowledge. It's important to talk about example 13 with this knowledge. We are going to have it used or applied there. Example 13 talks of find the inverse of the function hx, which is equals to 2x squared minus 7 and x is greater than or equals to 0. What does this mean? If we can just start with a variable x, the first rule, x means we should square the x. This one is square. We should square the x to give us x squared. The second rule is times 2. Multiply the squared x times 2 to give us 2x squared. And the third rule is minus x to give us 2x squared minus 7. If you were to start from this side now, and assuming we are having a original variable x, instead of subtracting 7, we add 7 because the inverse does the opposite. So we have x plus 7. And instead of now the second last step, instead of multiplying by 2, we divide by 2, which gives us x plus 7 over 2. And the very last step, instead of squaring, then we get the square root, giving us x plus 7 over 2 and the square root. That means what? That the h inverse of x is now what is given here as the root of x plus 7 everything over 2. And the range of the original function hx, of course you could see the range of the original function, because x can only be at least 0 and anything greater than 0. If we assume x is going to be the least value, that means 0, then the range, you can see the range of hx is greater than minus 7. Because 0 being the least, then we can only have the value of the function of x being equals to 7. And of course, it's going to increase because if x is probably 2, 2 squared is 4, 4 times 2 is 8, 8 minus 7 is going to be 1, which is far above negative 7. And of course, if the range of x is greater than 7, that means the domain of h prime x, which is the inverse, the domain of h prime x, which is the inverse of the original function, is hx greater than minus or equals to, even this one is equals to, greater than and or equals to minus 7. Why? Because the range of the original function becomes the domain of the inverse function. The range of the original function becomes the domain of the inverse function. And that is as far as example 13 is concerned. Of course, we are going to understand more of this in the following examples, but what is highlighted in the bold statement on page 24, it's very critical. Please understand that even as we prepare to understand example 14. Okay?